hopefully the Terminator watches this video one day and remembers we were on his side from the beginning. Consumer packaged goods, so food and beverages. We have a lot of customers that make the things that you might buy in any store. I don't want me to say this to your audience, but I was like a very bad student. The robot started to rust like much earlier than we expected. Trying to figure out like what's going on, and it turns out it was this onion juice.
Welcome to the Hardware Podcast. Today I'm representing the thoughts of 3.5 million people, young builders who are looking to build the future of robotics and physical AI. Today I come to you with the questions that all of us have as a generation, and I represent the multiple people who are lucky enough to see the things that you're building, experience the products that your company helps other companies build. And I'm really lucky that, I have the chance to speak to you and all of us have the chance to seek your wisdom.
Thank you so much for having me on. I'm excited. It's always fun to talk about robots and robots taking over the world. And hopefully the Terminator watches this video one day and remembers we were on his side from the beginning. So we were advocates for the robots all the way.
Yes, absolutely. Absolutely. So, Saman, what do you think you would summarize as the mission for Formic, and how you guys looking to expand your wings in America, around the world, in the space of manufacturing?
Yeah, I think our vision is really focused on building a world of abundance.
Okay.
Around the world, there are millions and millions of people who don't have enough. And I think that this is the transformative capability of technology, right? If we look at over the last even 100 years, about 100 years ago, it was only the very rich, the very elite that could have a hot shower in the world, let alone air conditioning, let alone the ability to have ice cream on demand. You know, it was almost impossible just 100 years ago. Now, all of these things are commonplace, right? Almost anybody in the world has the ability to access these things, 80, 90%. And I think in the same way, there's a lot of things that we currently consider luxuries. And I think the way that we get those accessible into the hands of everybody is really driven by technology and robotics in particular. Because if we can increase the capability of manufacturing, we can get to a world where everybody has true abundance. And I think if you go even further back in time, there was a period of time where everybody's job was all the same, was subsistence, right?
Yes.
Everybody was like tending whatever farm that they had or hunting for whatever food was nearby. And that was the only option for the majority of the world, the majority of the population of the world. Today, globally, less than 1% of the population of the world is working on agriculture or like actively doing farming. Right? A lot of people in the world are able to do all these other things. That's how we were able to develop, or at least in America, sorry, it's less than 1%. I think globally it's more than 1%. But that's how we're able to develop systems of politics and art and sciences and philosophy and like beautiful books and all of these things come as a result of allowing people to not just be worried about subsistence. And I think that's really the magic that technology can bring, and that's what we're working for.
Perfect. In terms of how Formic started, you were part of two very prestigious institutes and also had a full ride when you were in university. So, when you started as a builder, how did these experiences come together to help you begin Formic?
Yeah, so I actually started my first company when I was 14 years old,
Oh,
and it came from part of it. I think was I was inspired a little bit by my dad, who was an entrepreneur as well. But when I saw that, it's possible to just make things, and then you actually can make money by making things. For me, that was the unlock. I never wanted to be an employee again. Uh, Not because working for somebody there's anything wrong with it, but because um, for me, I found the idea of having something start as an idea in your head, and then eventually it turns into something that's in the real world. It's just so addictive to be able to see that, this process of creation. And I think in many different ways, many different people create. You're creating incredible educational content. lots of people are able to create, art and other things. I don't know how to do any of that stuff, but I can make stuff. I can build companies. I can build robots. I can build technology. So like that's the thing that I think allows me to have a creative output into the world, and that's what I find to be really really valuable and meaningful. So when I decided to start Formic in particular, definitely it was like the accumulation of a lot of different experiences. I got to spend a lot of time in China. I got to spend a lot of time in manufacturing. I got to spend a lot of time in venture capital. I got to work with a lot of startups and software, and I saw all those things that were happening in the world around me. And then we were investing a lot in AI, and for me, it became really clear the place where AI is going to have the biggest impact is going to be in the physical world. That's where we all live our lives, and at least until Elon Musk uploads our consciousness or something. But for now, we live our lives in the physical world, and it's very important for us to solve all of the problems of just drudgery and tedious, painful work that happens in the world around us. So, uh, the combination of all those experiences, definitely, my university, my time in university, my time doing my master's and MBA program, my time as an entrepreneur in the past, all of these accumulated in what ended up turning into Formic.
Perfect. When you began Formic, how did you form your initial team? What became something that you guys focused on? And how did it finally come to manufacturing? Which segments are you guys specializing in?
Yeah. Um, they say first time founders worry about product, second time founders worry about distribution. And that's really what I realized was lacking in the world of robotics. There were a lot of like brilliant PhDs working to create the next robot, to make it do a new backflip, to make it do some new trick. All that is fantastic. But what I realized was even the things that robots today already can do well are there's very little adoption.
Correct.
And technology is not useful unless people are using it. Diffusion of technology is much harder than invention of technology. Um, so that's what we decided to focus Formic on was let's look at robotics and the categories of things that robots can do well, and then let's find all the places where that should be applied, but there are frictions in the world that prevent that adoption, and let's go and solve them. So what that ended up with is quite a complex company, right? We built a footprint of people all across the United States who can do robot installations, data collection, model training for specific tasks, fine tuning. We do all of the robot financing. We do all of the ongoing maintenance for the robots, and it really allows these end users who are generally not sophisticated robotics companies, but are just regular businesses to be able to call us and say, I need a robot to do XYZ, and we can show up with the robot and it will do XYZ. And that sounds simple, but behind the scenes is very difficult to accomplish. So being able to actually deliver the robot that works consistently and reliably with 99.9% uptime is really difficult and is the thing that we focus on. We really mostly work with factories. So there are factories in the US alone, there's about 500,000 factories globally, obviously many, many more. Everything that we use in our lives basically comes out of a factory, right? Like the clothes you're wearing, this chair you're sitting on, the
Mics
the,
we're using.
the mics we're using, the food. Most of the food we eat
Yes.
has gone through some kind of processing facility, whether it's going from the farm to someone who packages it. Snacks that you buy, the boba that you drink, right? Like everything has gone through a factory. These are the places where really like the substrate of our entire lives is built, and that's where we try to serve. Those are the people. In the U.S. in particular, this is a big problem because most factories in the U.S. were built in like the 1920s to the 1960s. Right? Like that period of time was the big boom in American manufacturing. And the reality is, most factories then really never evolved since then. So they look the same today as they did 50, 60, 80 years ago. And we think that there's a lot that we can do to solve that. There's a lot of technical changes that have happened that allow the robots to do useful tasks. And it really has given new life to these factories that can now produce more, accomplish more, and build better products that we all use every day. So the three sectors that we focus on, to answer your question directly, biggest one is consumer packaged goods, so food and beverages, We have a lot of customers that make the things that you might buy in any store, grocery store. The second big sector for us is metal fabrication. So our robots are helping to make automotive parts, aerospace parts, parts for lawnmowers and golf carts and dishwashers and uh, heavy mining and drilling equipment, all kinds of metal parts that these guys use. And then the third sector that we do is plastics manufacturing. The plastic parts are going into many, many different sectors as well. Automotive is still a big one, a big user of plastic parts in the US, but also, um, you know, golf carts and all kinds of consumer electronics. All of these things use a lot of plastic parts. So those three are the main ones that we focus on today.
Perfect. When it came to beginning Formic, you mentioned that you had a few other companies before this that you worked on. So, what from there did you bring into Formic? What were the learnings? What were the experiences that you remember and that have contributed to forming such a big company?
So the companies that I started in the past, I started two software companies. I started the company I started when I was 14 was we were just building computers and selling computers. Um, uh, and then I also started a venture capital fund, and I ran that for many years. All three of those experiences gave me slightly different perspectives on what it means to build a company. And I think some of the lessons that I took out of that were primarily around people and culture. I think that really is the most important thing. I think Vinod Khosla has a very famous line that the people you hire is the company you build. Something I might be butchering it, but something along those lines, right? Which is
Yeah.
the company really comes out of kinds of people that end up joining early on. And, there's a really interesting moment in time today where AI has really changed the profile of the kind of person that you might want to look for. In the past, I think you would really look for experts in different fields, and you needed expertise in, let's say, accounting, or you needed expertise in, some specific aspect of how to build some specific technology component. The reality is now, actually, AI has raised the average expertise level of basically anybody to be able to learn what used to be very complicated and exclusive knowledge. So I think what matters the most today is people who take a lot of initiative and people who are creative and have good taste. I think it's a phrase that other people have started using. I'm kind of copying it, but it's very hard to define what good taste means. Maybe the way that you find good taste is people who have similar taste to you or something. I don't know. But ultimately, you want people in the company who can actively work really quickly, who can iterate across many, many different ideas, who can quickly learn new skills and new tasks, and then you can translate that into action and build really meaningful things. And so I think that's the biggest number one lesson that I've learned coming into Formic and even during my time building Formic. The second thing that I think was a big takeaway from my time at Formic is this idea that there's no such thing as like an 80% product to your customer. Like either you solve 100% of the problem or you solve 0% of the problem. There's no in between. Like you
Yeah.
can't go to a customer and say, "Oh, I have this, but to make it work, you also need X and Y, Z, and you need to do this and you need to do that." Like that's not a viable product.
Yes.
So a viable product has to be you go there and you say, "This solves 100% of whatever problem you have." In our case, in manufacturing, it's empty headcount. Right? These factories have people that they need filled. We need to go and we need to do 100% of the task,
Yeah.
right? If it's picking and placing things or packaging things or loading and unloading some piece of machinery. And to do 100% of the task requires significant time and energy investment and polish and ease of use product for like a non-expert audience. So I think those are the two big learnings during my time before.
Perfect. I have two allied questions. First, what are the problems from the robotics technical side of things that you saw while bringing these robots to the actual factory floors that you think are yet to be solved? And let's say you're bringing somebody on board, an engineer is looking to be part of Formic and to build the next generation of factory automations. How do you think someone can look at this from a problem statement perspective? And how, as an engineer, would you say that we can bring this together and work on it?
Yeah, so I think the technical challenge in robotics is around operational performance. Meaning, like if you're in an academic or a lab environment and you get a robot to work 95% of the time, like, that's a huge win. If you're in a manufacturing floor and your robot only works 95% of the time, that's a giant failure. Because, like, any of the robots that we deploy typically on any given day, they might do 10,000 cycles of whatever task.
Yeah.
So if you're 95% accurate, that means a few hundred times per day you're failing, right? Which is just completely unacceptable. So I would say, I think in a manufacturing setting in particular, reliability and like having a system that's bulletproof is much, much more difficult than it might seem. Because the kinds of factors that could influence your robot are numerous, right? Like on the algorithmic side, the vision system needs to be robust to whatever unexpected obstruction there might be. Right? Maybe the cameras are blocked, maybe the cameras are dirty, maybe there's dust in the air, maybe there's sunlight that's directly shining into the lens. There could be 100 things that happen, and you have to have redundancies for all of them. On the mechanical side, motors fail, sensors fail, wire harnesses fail, and again, you can't stop production. You have to be able to continue with some kind of redundancy, or at least be notified early. And then on the control side, or like linking all those things together, even on like a material science angle, it's difficult. Like we had a robot that we deployed one time into a factory that was making prepared salads. We are like, oh, like nothing's scary about prepared salads. But it turns out in the room next door, they also were preparing like bags of chopped onions to sell to the factory. And the bags of chopped onions, in the process of chopping onions, like the onion fumes go in the air and they land on the motor and the joints of the robot, and actually it ended up being super corrosive. So the robot started to rust like much earlier than we expected. We were trying to figure out like what's going on, and it turns out it was this onion juice. So building onion juice resistant robots is not easy. But that one's kind of like a little bit of a joke example. But there's just so many things like that that can go wrong once you're in the real world, and that's really what's different from software. In software, you build it, you deploy it, and even if something goes wrong, it's very easy to fix it. In the physical world, if you take a $150,000 robot and onion juice starts to rust it, you're out of luck. You have to spend probably $100,000 to get that thing back up to running. So it's really, really like the cost of failure is so much higher. So to answer your second question around like what young people should be looking for, I mean, I think the number one determinant of success in any person, I think especially any young person, especially today, is their willingness to just try stuff. Right? Like when you do it and you try it, you learn. I think there's a lot of people who sit around and plan and plan and plan and ideate, write stuff down. They think about what they might do one day, or they make excuses for why they didn't do it, or why they might not do it, or why it's hard, or why it's easy, or they try to do research about what other people did. All of that stuff is nice, but nothing beats just getting your hands dirty and getting in the field and doing stuff. And so that's something we encourage everybody at the company to do, is like really be willing to kind of jump to the front lines and go solve problems. And if we don't know what the answer is, we try not to spend a lot of time debating it. We just jump in and try many approaches and see which one works. And that's a culture that's really hard to build, especially in an industry like manufacturing, where historically it's very risk averse. And being able to work in a risk averse environment but still take a lot of risks, it's a little bit of a dichotomy, but you still have to figure out how to overcome it.
Yep. Well, that makes a lot of sense. If you were to predict 3 industries in which robotics would be most applicable, which would the 3 industries be?
I think manufacturing is the biggest one.
Within manufacturing, which would it be?
Within manufacturing, Oh man, really, it's everything, right? I would say like where it's probably easier to say what's not in manufacturing, which is I think like semiconductor manufacturing and like small like electronics manufacturing. Those have already been pretty highly automated, um, and because they're super high volume, they're super consistent. Basically, everything else is still manual. I'll give you like an example of some data. In the U.S., 90% of the robots that are sold are sold to the automotive industry, and of those 90% of robots that are sold, another 90% of them are used for just painting and welding. Um, so all the other tasks that happen in automotive are basically not automated. And I think that, and outside of automotive, which is really in the U.S. the most advanced users of robots, basically everybody is not. So I think that there's tons of opportunity in food and metals and automotive and aerospace and all kinds of manufacturing tasks. Like slightly adjacent to manufacturing, I think there's also a lot of like less structured environments where you're doing basically manufacturing. I think construction is a big one, and agriculture is another big one. I think those are two spaces where automation for a lot of tasks still hasn't really been done. There's a lot of opportunity. Healthcare is another place where still there's a lot of very manual work. So I think that we're entering the era where we're moving from super specialized robots to these kind of. I'm not a huge believer in total generalized robots. Like completely humanoids, I think is not really the best trade-off. But there's this kind of middle ground where they're somewhat specialized robots.
Yeah.
And those ones I think will be able to serve a lot of industries.
Perfect. When it comes to companies that you would bet on personally with ancillary parts of robotics, for example, something that could do the fixing. Now, I know Formic does a lot of it, but when it comes to investment from your standpoint, in terms of something that could bring revenue into the robotics industry in general, what would you say? I've heard a few people mention guards for robots in case they fall in the case of humanoids. But something of that sort for Formic, what would you say?
I think some areas where we think there's a lot of room for improvement, kind of related to the themes that you're saying, is robot safety is kind of an unsolved problem, right? So these kinds of robots are small and
Yeah.
can't really hurt you. A lot of the robots we deploy are huge. They're much, much bigger. They can move 50, 100 kilogram payloads. They move fast. In those environments, human is really in danger unless you build a ton of safeguards. So we then have to do a lot of work to safeguard the people. So we put cages around the robot, not to keep the robot in, but to keep the people out, right? We also put a lot of things like light curtains and LiDAR scanners and radars to keep an area safe and make sure that if there's a person in the loop, that the robot stops. That is really, really difficult and very expensive. And we think that there are better approaches using vision and more modern approaches. But there's a kind of safety certification process that you need to go through before it's usable. So I think there's a lot of opportunity for people to kind of break new ground there. On a related note, I would say there are a lot of the kind of component level systems in robots that are imperfect. I think sensors is probably the biggest one that I'm thinking about. So I think tactile sensing is one of the things that's going to be really necessary to solve in order for robots to be significantly more productive. You and I have hundreds and thousands of sensors on our hands, and we can detect temperature, we can detect surface material texture, we can detect force and pressure. We can detect a lot of things with just these two hands. It's like pretty magical, actually. You can detect if you're holding something, if it's slipping, you can feel that. That's really hard for a robot to do. And without that, the robots actually really have to fumble around and kind of guess. And we think that there's a lot of opportunity for robots to gain tactile sense. And then I think at the component level, there's still work to be done on the actuator side, like motors and linear actuators. But there is a lot of investment going into it today. There's a lot of competition on the actuator front. So I don't know, it's also a pretty heavy investment to really be able to innovate heavily there. Yeah, and then on the software side, I think there's a lot of data collection tooling that's missing still. Really high quality data collection that allows regular people to collect huge volumes of data that you need to train these robots easily is still very much missing.
When it comes to like the journey you had as an academician, meaning as a student, how did you bring that into building a robot like this? And what do you think are the gaps that you would fill right now with your education in the physical world?
So probably you don't want me to say this to your audience, but I was like a very bad student. Um, because not because I wasn't curious, I loved learning, but I hated feeling like I had to perform for the exam or for the teacher. And so I would just kind of go my own journey. And so I would get bad grades sometimes, but I would learn the stuff that I was interested in. So for example, like when I took calculus, honestly, I didn't learn anything, so I got a pretty bad grade in calculus. But then when I had to learn thermodynamics, I was like, oh, this is so cool. I'm curious to learn about how heat moves around. And in order to solve thermodynamics equations, I had to learn calculus. So then I went back and I learned calculus, and then I went and solved my thermodynamics equations. So I think the same thing goes for many, many subjects that I did, which is like, for me, if I didn't know why I was learning it, I just couldn't. I just couldn't pay attention to it. So I have kids now. Hopefully, they're better than me in that sense. But I think that it is kind of this. We are also entering a new world with AI, which is the things you need to know and the things you need to learn are very different than in the past. I still haven't really formed a strong conclusion around what that means and what it looks like for students, but I think the thing that matters is flexibility. Right? You have to be creative. You have to be flexible to learn new things. I think the people that are the worst at our company and any company are the people who think that they know everything and are not willing to learn new stuff, right? Because that's just like that's a death recipe. Because even if you knew everything at one moment in time, 6 months later, it's outdated. And so any level of confidence that you have in your own knowledge is completely unwarranted. So being able to be humble and continuously learning is hard. I would say the other thing that I think from a student's perspective is really important to develop is this idea of creativity. I don't mean creativity in the simple sense of like, oh, I could like draw a bunch of pictures or make some music. Like, oh, those are great, but I think there's many different ways to express creativity, and I think learning from the things that other people do, and then also like really training yourself to be a creator rather than a passive recipient. Right? So I think a lot of people spend a lot of hours on social media, just watching content, consuming information, and like any minute you spend consuming is the minute you're not spending creating. It doesn't mean create content, but you can create anything, right? Like, so I think training ourselves constantly to like be in this creative mode and exercise our creative abilities is really, really important. And I think students in school today need to really think about that because schools also don't really train you to be creators. They mostly train you to be recipients. Right? You watch the teacher talk, and then they tell you to fill out a form, which is the exam, and you fill it out, and then you're done. Right? Like it's kind of in the process you are learning, but I think this kind of creative force that we all have in us is so important and it's not being used often enough.
Now that Formic is moving into a new facility in San Francisco and you guys are building a new team as well, what would you hope for in some person from our ambitious builders who are looking to be part of Formic? What kind of creative segments in robotics are you looking for? What is three different skills or three different ideas that you would look at and say, yes, I want this person to be part of my team because they will contribute to a world that's better than what we have right now?
Um, I think I talk about creativity a lot, so I think I would put that as number one, right? And to demonstrate creativity to a company that wants to hire you is really hard. So there's no one way to do it, right? If I was to give any answer, it would be the wrong answer because everybody has their own way of expressing creativity, and I think we've seen like really incredible ways that people have demonstrated that to us in their application process. Um, the other thing I would say is like just this idea of taking initiative is super important, and So to be honest, like if somebody just applies to a job on the website, they've done the minimum, right? Like that's the most basic minimum amount you could do. So what else did they do to try to get this job? Did they reach out to me? Did they try to find somebody? Did they look for introduction? Did they write something special to send to us? Did they do a project? Like just it doesn't matter even so much the quality of the thing that they do, but just the fact that they show that they're willing to do a little bit of actual work in order to get a job, I think it means a lot, and it's surprisingly quite rare. And then I would say the third thing that really matters for people who are interested in a role at Formic is to know what job you're trying to get, and then like really target that, right? So if you need a specific set of knowledge or expertise, to like do the preparation in advance to go and learn about the thing. Even if that's not your major in college, it doesn't matter, right? Like we don't really care that much what you study at school, but demonstrate that you know what you're talking about when you show up. If you're going for an accounting role, like know a lot about accounting, talk about the latest things that are happening. You know, like I often ask in interviews the question, like, what are some of the latest things that are happening in XYZ field, your field? And some people clearly have been looking at it and reading about it all the time. They have a bunch of ideas like, oh, this happened, that happened, AI this, here are all the ways that people are using it. That's so cool. And some people just have no answer. They have a blank stare on their face. And they're like, what? Something new in my field? They just learned it in school and that's it. They were done. So I think it demonstrates this kind of lack of humility to kind of continuously learn.
Yeah, that makes sense. Do you have anything that you are looking forward to in terms of Formic making it in the world? What would you say is a benchmark that once Formic hits would be something you'd be extremely proud of, or something you will finally pat yourself on the back for?
I think the curse of the founder is that you just never really have an answer to that question. It's like there's always more to do and more to accomplish.
What's the 2026 goal?
Uh, I won't say the exact numerical goal, but we have a very ambitious target for the number of robots we want to deploy this year, and it's many multiple of what we deployed last year. And so that's when everybody on my team saw the number, they were like, "It's impossible. There's no way you're making shit up." And lo and behold, here we are in June. We're on track, right? So I think it's hard, but we're working towards it. On the other hand, I would say in the long run, I think really true success for Formic really means that the world is rid of drudgery, right? Like people don't need to spend time, just doing the most boring work. I went to a factory a few days ago where they're making shampoo, right? And there was a line of 50 people, and their job was just to put the cap on the shampoo bottle and twist it, and then put it away. And they would do this. They would do like 3 or 4 of them, and their hand would hurt so much. They would shake it, and then they would do it again, right? And imagine you have to do that for 10 hours a day, 12 hours a day. I couldn't do it for 1 hour. So it's really, really, a human is so noble and has so much capability and creativity. Every single one of those people on that line, on that production line, had ideas, had thoughts, has capacity to learn. And there they are spending all of their time doing this super repetitive, super belaboring task. So I think my hope for Formic and for the world as a whole is like we need to elevate the station of the human being, and in order to do that, we need to also resolve what is thought of as drudgery.
That makes so much sense. I think Formic is headed towards a year full of achievement. I know that you guys are expanding on multiple different fronts, from a technology perspective, from a facilities perspective, from a team perspective. I think all of this is great for Formic, and I think a lot of us are interested and very excited for the manufacturing work that's coming up. Thank you so much for being on the Hardware Podcast.
Thank you for
It's
having me.
lovely
This is
having you.
awesome. I had a lot of fun.